Hello, I am Dr. Sigarkanti, Associate Professor of Mathematics, Government First Grade College, KR from Bangalore. In this video, I am going to write a program in Python to find the generators and the number of generators of a finite group and verifying this with the pi function. Okay, suppose G is a cyclic group and it is generated by some element A, and say order of G is equal to n, then a power of k is also a generator, if k comma n is equal to 1. Okay, suppose we have order of G equal to say 20, then and if G is a cyclic group generated by A, then what are the generators here? A is a generator. A square is a generator? No, because 2 is not relatively prime with 20. A cube is a generator? Yes, because 3 is relatively prime to 20. A raised to 4 is not a generator. A raised to 5 is not a generator. A raised to 6 is not a generator. A raised to 7 is a generator because 7 is relatively prime to 20. And the a power of 8 is not a generator. A raised to 9. Yes, this is a generator because 9 comma 20 is equal to 1. This is a generator. And a power of 10 is not a generator. A power of 11 is a generator. A power of 12 is not a generator. A power of 13 is a generator. A raised to 14 is not a generator. A power of 15 is not a generator. A power of 16 is not a generator. A power of 17 is a generator. A raised to 18 is not a generator. A power of 19 is a generator. So these are the generators. And our number of generators are 1, 2, 3, 4, 5, 6, 7, 8 generators are there. Okay, 8 generators are there. Now we can find this number 8 using our pi function. We have pi of n is equal to, that is here pi of, in this case it is 20. We have the formula 20 into, if we write this 20 as like this 4 into 5, and this is 2 square into 5 to the power of 1. That is here the product of powers of prime numbers. So in this case this 2 is a prime number, 5 is a prime number, 2 square into 5 to the power of 1. Then pi of 20 can be written as 20 into 1 minus 1 by 2 into 1 minus 1 by 5. This is equal to 20 into 1 minus 1 by 2 is 1 by 2 into 1 minus 1 by 5 is 4 by 5. Okay. So here 5 into 5 into 10, 10 into 2 is 20. That is, finally we are getting 4 into 2 is equal to 8. So pi function is equal to the number of generators. Now, when do we say that given element is a generator? Suppose order of G is equal to n, and if there exists an element whose order is also equal to n, then we say that this A is a generator. Okay. So if we have order of A equal to n, then this implies A power of n equal to identity element. But converse is not true. That is here, if A power of n equal to E, then we cannot say that order of A is equal to n, because here n need not be the least positive integer. Okay. So in this case, we can say that order of A is less than or equal to n. So what I do here is, while writing the program, first I will take an element here, an element A in G, and I will verify whether A power of something. So say if I take I will use the for loop here. I equal to 1, 2, 3, 4, 5, 6. up to n I will consider. And here for this a I will check a power of 1, a power of 2, a power of 3, a power of 4, a power of 5, like this. Okay, up to a power of n. Now here in between, suppose here if we get a power of k equal to e, then a power of k to the power of something. Okay, this is some element here. Okay, this a is some element here. If I get that element to the power of k equal to identity, then k is this a power of k is not the generator, because here k is not the least one. Okay, so what I do here is I will check I'll find the orders of the elements of the group G. If that order is equal to n, then I will take that as the generator, and I will define one set here, empty set here, and every time I am going to include this this element, the generators, in this set. Finally I will print this yes. So we can find the generators, and the number of elements in this set is nothing but the number of generators. Okay, and how to find the pi function in Python? What I do here is, first I will assign say pi of n is equal to n. So I have to find out this. For example, if I take n equal to 20, I have to find out this 20 into 1 minus 1 by 2 into 1 minus 1 by 5. Okay, so in this case this 2 is a prime number, and 5 is also a prime number, and 2 divides 20, 5 also divides 20. In that case, what I do is, for the first time I will use for loop here. First I will take this 20, and next time we add this 1 minus 1 by 2. We multiply this with 1 minus 1 by 2, and next we multiply this with 1 minus 1 by 5. So that is to find this term. I had to find out this 2. What is this 2? 2 must be a prime number, and 2 must divide 20. Similarly, next 5 must be a prime number, 5 must divide 20. Then we can find out this pi of n. Okay, so let me go to Python. So here write program to find the number of, find the generators and the number of generators and finding pi function finding the pi function, and verifying this pi function is equal to the total number of generators. Okay, so here I have used hashes here. This is for the comment line. Okay, so what I do here is here SymPy is not required actually. Okay, because we are not using SymPy. Okay, not using. Okay, let me write G equal to, I will consider the example G equal to this group 1 minus 1 I minus I, and we know that this is a group with respect to multiplication. One is the identity element, and one is the identity element never be a generator. Minus 1 is not a generator because its order equal to 2. I is a generator, minus I is also a generator. So number of generators equal to 2. Then pi function is also equal to 2, because here we have n equal to 4. Okay, so we write G equal to 1 minus 1 minus 1 I means 1j comma minus 1j. Okay, this is our G, and then we define a set here S equal to empty set. So that is, I am going to include the generators in this set. We define a set here, and next we use for loop for take an element A in G, and I will check for this A uh, uh, up to the order of G. Okay, so that is we use one more for loop here for I in range, 1 to length of G, G. I have to write plus 1 here. Okay, because if I use for loop, it takes starts from 1. I take the value 1 and takes 1 less than this, so I have to go up to 4 times here. So therefore I have to take 4 plus 1, that is length of G plus 1. We have to put a colon here. Then I will check if uh, a to the power of I, is equal to means I have to write equal to the identity element. In this case, identity element is equal to 1. Okay, 1. And but if I get a power of I equal to 1, I cannot say that I is the order of A. So if I is the order of A first time, but we cannot say that it is the generator. This becomes a generator if this I is equal to n, that is the order of A equal to order of G. Then we say that A is a generator. So for that I will go for if I equal to length of G. Okay, I equal to length of G, then A becomes a generator. Otherwise, it is not a generator. So we print single quote. Okay, first I write that element A, comma, single quote, is a generator. A single quote, close, bracket, close. And if A is a generator, I will include this A in this set S here. So that is we write S dot update this element. So that is we have to write this in open bracket. Within the square bracket, I have to take A, close this square bracket, close the bracket. Okay, and then if, so that is print. Okay, if I is not equal to length of G, for example, if we take minus 1, if A equal to minus 1, what I am getting here is this minus 1 to the power of 2, I becomes 2, E is equal to 1, but I is not equal to 4 here. Then what I do here is I will skip this one. So we give a break statement here. Then, so now we got S here. That is the set of all the generators. Next, if there are generators, then some elements are there in this set S. Okay. If not, no generators are there, then this set will be empty set. So what I do here is if length of S is equal to 0, means no generators. So print G has no generators. Quote close, bracket close. Else I have to write this in if line. Okay, else colon print number of generators equals how many generators are there, that is number of elements in S, that is it is nothing but length of S bracket close. Okay, now so we found the generators here up to this for the generators. What are the generators? And number of generators are here. Now we try to find out the pi function. For that I will write n equal to the order of g, that is length of g. I'll take this as a n. Then I define pi of n, say PHI OFN. You can write anything here. This is a variable name. I am writing pi of n. For that PHI OFN I am writing. This is equal to, initial I will take, this is equal to n. And then I'll go for this. Yeah, first I will take pi of n equal to 20, and then I will go for this one, that 20 into 1 minus 1 by 2, and then I will go for 20 into 1 minus 1 by 2 into 1 minus 1 by 5. Okay, so that is, I will use the for loop here. For I in range 2 to n plus 1 I have to write. I have to go up to n here. So I have to write n plus 1 bracket close. For is there, I have to put a colon. I press the enter button. If I is a prime, so here see this 2 is a prime and 2 divides 20, and 5 is a prime, 5 divides 20. That is here, if that number I is prime and that number divides 20, then I will consider this 1 minus 1 by 2. So that is, if we have that number is I, then I write, if I is a prime and I divides 20, then we write 20 into 1 minus 1 by I. Okay. So here, if is prime I, that is I is a prime, and I divides 20 means n% I equal to 0. Put a semicolon, put a colon, because if is there, then what I do here is, just a minute. Okay. Yeah. Then I will update this pi of n. PHIOFN equal to previous pi PHIOFN into, that is into star, means star, into 1 minus 1 by I. Okay. First time it includes in that example, if it is 20, then I have taken this is equal to 20. Okay, pi of n value is equal to 20 into 1 minus 1 by 2. Then 20 into 1 minus 1 by 2 into 1 minus 1 by 5. Okay, so finally, after finding this, coming out of this for loop, I will print this. Print pi of n. You can write in capital or small, no problem. Pi of n equal to close the single quote, put a comma. Here I have to write this variable name. Variable name is PHIOFN. Okay, small. PHIOFN. Bracket close. Okay, this is the program. Let me run this program. Getting late. Okay, some error is there. Yeah, some error is there. This I have to write in set notation. I think it is okay now. I run this program. Some error is prime is not defined. Okay. Uh, so I have to import from SymPy import star. Okay, I think pi of n is not pi of n. I think I have defined PHI of n equal to n. PHI of n. PHI of n is prime. Okay. Now I will run this program. Yeah. See, minus I is a generator, total number of generators equal to 2, and pi function value is also equal to 2. And if you give int here, you are not getting this decimal point. Let me write, if I write this as, if I make this as int, open bracket, and close bracket, I will get integer form. If I run this program, see, I am getting pi of n is equal to 2 without this decimal point. Okay. Now I will go to another example. Next example is g equal to 0, 1, 2, 3, 4 with respect to, this is with respect to addition mod 5, and I think in this the manual it is wrongly printed as multiplication model of 5. For multiplication model of 5, this is not a group. Okay, so I have to change g equal to 0, 1, 2, 3, 4. Okay, and here, see, here in multiplication, a square means a into a cube means a into a. But in with respect to addition, a square means a plus a cube means a plus a plus a. And if it is addition model of 5, then a square means a plus a, that is 2a mod 5. A cube means a plus a plus a, 3a mod 5. Okay, so that means here I have to write this as I star A, and the identity element in this case is equal to 0. I have to change this identity element 0. Okay, next thing is I think everything will be same. I think rest are same. Okay. Now if I run this program, G has, okay, something is wrong here. I star, okay. Here I had write that operation I star A percent 5. Okay. Now this is correct. Next, these operations are not there in the rest of this program. Okay. If I run this program, 1 is a generator, 2 is a generator, 3 is a generator, 4 is a generator, and number of generators equal to 4. Pi of n is equal to 4. Okay. Next, I will go to another example. G equal to the set 2 comma 4 comma 6 comma 8 with respect to multiplication mod modulo 10. Okay, so we have to change here, and this is the comment, and if you change here, then no problem. If you don't change here, then also no problem. Here I have to change. Here I have to write 2 comma 4 comma 6 comma 8. and my operation, this is multiplication modulo 10. So there, for multiplication I have to write a power of, that is a double star I, and percent, this I have to write percent 10, and I have to write the identity element here. Identity element here in this case is 6 is the identity element. For this group 6 is the identity element. Rest will be same. Rest will be same. Running this program. 8 is a generator, 2 is a generator, number of generators equal to 2, and pi function, that value is also equal to 2. Okay. Next I will go to another example. One more example. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 with respect to multiplication modulo 13. So here I have to change the elements. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and the operation is a power of I percent 13 I have to write, and in this group the identity element is 1, so I have to make this as 1. Now running this program, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Operation a double star. Okay. Running this program. 2 is a generator, 6 is a generator, 7 is a generator, 11 is a generator. Total number of generators equal to 4, and pi function is also equal to 4. Okay, both are same. Okay, thank you. I'll stop here.